Hi, this is János, Real World Audio, and we are back on our discussion on Ferrite and Alnico motor drivers, which is better for you. This is the third part, and I'm reading out the Audio Karma thread on peoples who posted on this matter what they thought which is better, and I'm reading those comments out and giving you my experience, how I can comment those comments. So for example, when you read these comments online, what is the context? And so I'm just putting them into context so you can absorb things better, and you can tell or orient yourself better in the world of loudspeaker drivers and their magnets and motors. So here we go. The next comment: in my opinion, a lot of love for Alnico comes from a close association with those top-shelf drivers that were meticulously engineered and perfected during the Alnico era, such as the JBL D130, D140, 150, the 4C, 175, 375, Altec 288, 515, 604, etc. Those of us who covet these treasures don't do so because they are Alnico. We covet these drivers because they are that good. If somebody made a driver that good out of cow shit, that's what I read, we'd covet that too. And this is a wonderful post, and he just summarized it so well that part of the why some Alnico drivers are really sought after. It's not just that the motors use Alnico, but because these drivers were really engineered to be that good, and really to make a great driver. It's not sufficient to just have good technology on your hand. You really need expertise, and you need hearing test, listening test. And at the Alnico era, people were much better using their ears to judge how their drivers sound. Today, the vast majority of loudspeaker industry is totally, entirely disconnected from hearing, listening what they have created. There are some exemptions, and those are the good exemptions, but those are really rare birds in comparison. So here's another post. Alnico magnets are more temperature stable than ceramic or ferrite, so if you are running high power, the magnetic field would not fade due to heat generated in the motor. Posted by Bob S. He's right. And let's dispel a fake myth. And that fake myth are that, oh, we change the motors because the Alnico can't handle the heat. No, I can show you that Alnico can stay the heat like no other magnet can. You wanna see it? I will see you the facts. I mean, show you the facts, not see you. You will see the facts I show. Okay. Have you heard of the company Arnold Magnetic Technologies? That's a big company working with industrial magnets. And here there is the table that they have provided, and I will read out to you guys from this table that lists the different magnet types used in audio drivers to compare their reversible temperature coefficients. So it means that what are the heat related damages that are caused to the magnets, to these permanent magnets, that come from overheating them, or just not overheating, but from heating them. What happens during their normal working range, and what happens when they're pushed beyond their working range, and when do they fail catastrophically. So there's the value that's called the TC value. the Curie temperature, which is where the driver permanently breaks down. So if you reach that temperature, then they lose their magnetization and they cannot be recovered. So they are pretty much toast. And let's see what is the temperature where they lose their magnetization. If we look at ferrite, that's 450 degrees Celsius. 450 Celsius. Let's look at Alnico, neodymium magnets. It's between 300 and 470 degrees. So it's even lower than ferrite. So neodymiums are more heat sensitive than ferrite magnets by quite a bit. And then let's look at Alnico, 900 degrees Celsius. So at that temperature, many of the metals already melt. So you need to melt metals to make Alnico magnet fail from overheating. And they are just so vastly superior in heat resistance. The Curie temperature is so much higher than ferrite or neodymium that it's just, look here. You see, Curie temperature, that's it. 900 degrees for Alnico 5. That's what is in my Altec 515C. And most Altec drivers have that Alnico 5 in them. And when you go down, lowest, that's ferrite, 450. And that's neodymiums in there. So basically, it's very hard to make an Alnico fail from overheating, but it's quite much easier to make neodymiums fail. However, why neodymiums nowadays don't fail? For two reasons. One, they pack the neodymium away from the voice coil so that the heat doesn't reach them so easily. Another, they make a lot of design and engineering features to ventilate the voice coil so the heat can get away from the vicinity of the magnet. And why is nowadays heating a question? Because nowadays, for the relatively inefficient drivers, we are dumping thousands of watts to generate high SPRs. And for Alnico magnets in the efficient speakers, we just less than 50 watts. So if you want to dissipate 50 watts of heat, that's very different than dissipating 1000 watts of heat. If you dissipate 1000 watts of heat, that's like it causes a rise like plus 100 degrees in Celsius in temperature compared to like 50 degrees Celsius. I mean a 50 watt power output requirement. Now, however, before that, before they reach critical failure at these very high temperatures, there is a max use temperature. So here, if you see that field, that's the field, max use temperature, and that's much lower than those values. So max use for ferrite recommended is 250 degrees Celsius. And how much is that? That's really, really hot. That's baking, searing hot. And for neodymium, the maximum use temperature is between 100 degrees and 180 degrees Celsius. And just to say, the max use temperature for N50 or N52 grade neodymium magnet that you can commonly buy, and a lot of people build speakers using that, is just 60 degrees Celsius. 60. That's just warm, barely warm. So neodymium is way, way more sensitive to heat, and you have to be very cautious to vent away the heat, because if you get it close to 100 degrees Celsius, you are taking it close to catastrophic failure. And now let's have a look at Alnico. Look, 520 degrees Celsius. So that's way beyond the temperature where wood burns. So it's kind of like your speaker cabinet would be on fire long before that temperatures are achieved. Uh, so 500 degrees is ridiculously high, and loudspeaker drivers never get that warm, never get that hot, and even if you abuse it like crazy, because uh, the temperature is much lower than even like 300 degrees. The voice coil former and the enamel around the voice coil wire, it can't handle not even 300 degrees, 200 degrees maybe max. Beyond that, the enamel on the surface of the voice coil burns up, and the voice coil is short, and your voice coil melts, and it just oozes out from the driver. And then when it plops down at the bottom of your speaker cabinet, burns through that, and then it burns, touches the floor, and your house catches on fire and it burns down. So we are talking about catastrophic failures which are well beyond normal operation. You would see things like this happening at like maybe like a King Crimson concert when they really crank the amp to 11. But in your home situation, high quality, high fidelity use, we never ever run into this situation. Uh, so basically that the heat, uh, the ability to withstand heat for Alnicos is way beyond that of ferrite or neodymium. There's a totally different ballpark. And that's why even today, for critical applications like medical, automotive, military, they still use Alnico magnets when really high temperature operation is required, because neodymium and ferrite are incapable to work there. Also, Alnico can work at very low temperatures, like minus 80 degrees Celsius, like Arctic cold. And ferrite, if you put it to minus 80 degrees Celsius, ferrite magnet permanently loses its magnetization. It just freezes, it fries. That's it. It's done. So Alnico is just vastly more temperature stable than any of the other magnet materials. And also, we have here what they what most magnetic companies don't provide you, min-max range. You see here like 20 degrees Celsius to where I'm showing there. That's the one, those two rows. Min-max temperature, that's the temperature range where the alpha and beta values are valid, and the alpha and beta values are the proper thermal properties of these magnets. So the alpha value is, it tells you that if you raise the temperature, the ambient temperature by 1 degree Celsius, then what is the loss of the magnetic field that happens? And as you see, all of the drivers, as we increase the temperature, the magnetic field produced by them shrinks. How much does it shrink? Guess what? The most sensitive to, who has the biggest shrinkage, it's ferrite. It's 0.2% per Celsius. So it means that if I raise the temperature of the magnet by 1 degree Celsius, it's going to lose 0.2% of the magnetic field on a temporary basis. So when the temperature goes back, the field expands again and it will become stronger. But if we are heating up, so if you have a really loud concert and then the temperature inside the driver is rising, then the magnetic field is collapsing. How much? Quite a bit. So for 1 degree Celsius, 0.2%, that's not much. But when we are talking about like pumping the thousand of watt of juice that nowadays they pump into those drivers, making them work at those extreme overheating situations. Now, if you look at, let's say, like, let's take a very extreme case, like adding 100 degrees of Celsius to that. then it means that what does that mean? So it means that we lose 20% uh, of the magnetic field. That's quite a bit, right? Wait, 20, 10, 20, yeah. 20% of the magnetic field is gone. That's quite noticeable. And you would say, that's not that much. But if we are talking about high fidelity reproduction, the ear really picks up on that. Like, oh, the tonality has substantially changed. And now, what happens with neodymium? The values go around roughly like 0.1, so half that of the ferrite. So here, the neodymium, from a sonic quality standpoint, has an advantage compared to ferrite, that by when you increase the temperature, the drop in the magnetic field is half that of the ferrite. So now, what about Alnico? Now, Alnico is 10 times less than the ferrite. So it's 0.02 uh, degrees drop. I mean 0.02% drop per Celsius. That's almost negligible. And the Alnico motors, they're designed to be high efficiency motors, which means that the temperature change is much more minimal compared to a comparative duty ferrite motor, ferrite loudspeaker. So essentially you can listen to very soft music or very loud music, and the tonality is the same. So that's one big advantage of Alnico drivers, that you have a set tonality. And that was the human hearing picks on, is there a change in the tonality? And even if there's a tiny change in tonality, the ear will pick that up, and it will register as a mechanical aspect of the sound. Maybe you won't be able to tell what's going on, but you can tell that it doesn't sound natural, it sounds mechanical. And that's why, because the ear can pick up those tiny things, and it will tell you that tonality change is something that our brain is very, very sensitive about. And for most of us, it goes at the subconscious level. And that's because when you talk to people, that's how you can recognize their voices. Like, oh, I'm talking to Jack, I'm talking to Jill. Now Kintaro is meowing, or Machiko is meowing. Which of the two cats meowed? They have different meows. Or if someone is here, I want to show you the different meow. There, you see, there's a different meow for you. So, and also when you talk to your wife, and your wife is upset, you hear the upset in her voice because her tonality changed. And that can be such a subtle change that's caused by like a 5% variation in the magnetic flux density for a magnet. That's big enough difference that if a similar change in the vocal cord modulation happens, then you get it that, oh, she's in a bad mood today, something happened, what's going on? And now, one more thing about temperature coefficients is the beta value. And the beta value tells you how susceptible the magnet is to external magnetic fields. So it means that this is very important when you have two-way speakers or three-way speakers, when there are multiple magnets close to each other, because they are going to be affected by each other's magnetic field. And when you are increasing the temperature of the magnet is becoming more and more susceptible to other magnets in its vicinity. And not just to other magnets, but the music that is modulating the magnetic field from the voice cord. So if your magnet is overheated and you crank up the volume, you will more substantially impact the magnetic field of your permanent magnet. And how much is that change? So the beta value will tell you that the more negative the value is, means that with the temperature increase, the sensitivity will be greater and greater to other magnetic fields. So it can be demagnetized easier. And now how easily? When we look at neodymium, it's bad. Really, really bad. It's 0.4% to 0.65% per degree Celsius. So it means that if we increase the temperature by 100 degrees Celsius, then the neodymium magnet will become twice as sensitive to other magnetic fields. So if you build a neodymium motor, you have to be very, very cautious that you run it very cool, because if you run it very hot, then if you are pumping very high level music through it, then it will demagnetize your magnet. Now, if you are far away from the Curie temperature, then this demagnetization will disappear once it returns to room temperature, so it's not going to be a permanent loss. But when you are in a concert, like an Aerosmith concert, and you are playing that neodymium drivers, like pumping out thousands of watts in it and running it sizzling hot, you can put the bacon on and it's ready in 2 minutes. That means that the magnetic field of that neodymium driver is going to fluctuate like, because it's super sensitive to the alternating magnetic field, strong magnetic field caused by the voice coil's current in it. And that's why you will hear a very, very strange modulation to the music. Now, let's look at Alnico. The beta value is almost 0. So if you increase the temperature by 100 degrees Celsius, then the susceptibility, how much more it's sensitive, it's becoming to demagnetization, increases by 1%. 1%, almost nothing. So Alnico is largely immune to the effects of heat as far as how stable its magnetic field is. Now, ferrite is a very, very fascinating thing, because it has a positive beta value. So it means that as the temperature rises, it will be more and more resistant to external magnetic fields. So basically, the hotter you run your ferrite driver, the more resilient it becomes to the changes in the magnetic field. So that's why it's a perfect solution for extremely high current demand loudspeaker drivers, because you can pump out tremendous wattage, it can overheat like crazy, and your magnet will stay and it will not be influenced. So you won't experience magnetic fluctuations in the field that holds your voice coil in place. And that's why concerts and PA applications love ferrite drivers, because they are just born and built for very high level, very high powered applications. So it's absolutely awesome. Now the problem there is if you are an idiot, then and you just crank your amp to 12, not even 11, 12, and you just get close to destroying those ferrite drivers, then beyond a certain temperature, it's not that it's becoming more and more resilient to external magnetic fields, it will at one point just collapse. And you can, if you push it beyond the working range, you can destroy it. But usually your driver, your voice coil will burn before that. Your voice coil former will catch fire before you reach that point. So many have tried and failed to destroy the ferrites by that method. So that's it. What else? So basically this is the physics about how they react to heat. So why is it that people report that Alnicos are not suitable to handling heat? The only reason is that heat enough by itself, Alnicos don't care at all about it. However, what they care is that when you have overheated them and you also bang them, or you give them a sudden mechanical shock, now you can permanently demagnetize them. Also, if there's just like a really high level of signal passed through that driver, like you really cranking it up to 11 for extended times, the very high magnetic field caused by the coil, not the heat, the magnetic field itself will damage the permanent magnet, will damage the Alnico, and you might, you might lose 2% of the permanent field of the magnet. 2%. Will you able to hear that? I don't know. Maybe yes, maybe not. But that's what you can lose, 2%. So that's it. So that's very, very dangerous, right? Losing 2%. Anyway, so we don't have to be really, really scared. Sometimes you can have, if your driver has the magnet has problems with it, you can have bigger problems. What usually manufacturers do, or guitarists who really crank their gear all the time, is that in the beginning, when they break it in, they just really crank it in until they smell the glue burning in the cabinet of the driver. And then if the driver survives that test, then it will never lose the magnetism beyond that point. And if it fails, they just get a replacement driver. It didn't break in, it broke, and they get a new one, break that in properly, and once broken in, it's permanent, it's stable, and it's good for life. So thank you for tuning in, and we'll continue. Oh my god, this is getting really, really long. I hope you are not bored stiff yet with this Alnico versus Ferrite series. And we'll continue. Thank you. Please like, subscribe. Have an awesome day. Bye bye.